Yeah, like right now, when you watch the video at home, you're going to hear her explain the whole thing.
That's why we actually see that.
Alright, so, let's go ahead and get started. We are currently recording, mainly.
Well, it's not really a very active one. It's not very strong. So,
If you don't believe me on that,
the Rift Valley,
wait
10
so
years.
let's talk about kind of a quick recap of what no one does last week.
We just don't see that here. It's kind of a while for us. I want to recap this a little bit.
We could talk about
I think
continental
one
drift.
thing we don't
Right
is
now,
you do
Alfred
have
Wegener.
the force
So that was looking
from
at
Eurasia
back
and
together.
so you have a force that's squeezing on the side. And then you also have the Pacific plate, that although it's sliding past California, that's a whole different plate boundary. Also, this colliding. It's actually really there is no we can then get a now
there's one more chain of lakes.
that you guys might not think of that much. So technology, which is does run on 1900 of early
Then,
ages
in
of
1960s,
that rock has
at the
been
beginning of the
recycled,
World Wars,
started to be
as well as through the World Wars, we
start
started developing some new technologies.
give us
Most of
big
which is
challenges
most
of
of
trying to
advances
find
in
good
war
solid
time actually
evidence
gives a lot of
of
scientific
places
feedback.
that are doing
So one of those was sonar. So with your constant
was
to get the big sonar had rendered the Atlantic Ocean almost completely impassable.
So,
Again, two examples.
There is a
huge group of ships called Convoy,
open up the
and
lake.
just like birds today, these ships in this big group hoping to one other. So right here are two pictures, both of the Himalayas. So that's not like the whole thing. So the Americans were really concerned about how to better detect
Why don't we find
in submarines to protect down. This image right here, very easily developed with
sonar.
sonar. And with sonar, we got that feedback that tells us the ocean floor was definitely not. So it's not that they were formed by the glaciers; the holes were already there. All the glaciers did. So the waters from the glaciers water. So all they do, the valley they force fill right there. So the Alps are actually pieces of the African plate. You guys ever heard of the maps? Did you ask Brent?
Same way is another ship get the divergent.
Actually,
Where they use it.
because it has the pools, the iron crystals will bind themselves, which that could actually explain some of the earthquakes we had in Washington, D.C.
Actually,
But
we
we didn't start putting two and two together.
And
So
it
yet
is
somehow stuck a little more spreading and put it with continental drift. It took our time to start looking at this. And then finally, we started developing this theory of plate tectonics in the late 60s and early 70s.
Okay, next one I want to talk about.
Last one I want to talk about is a transform boundary
to Earth science conversion.
Very, very new. A lot of you guys don't realize
What
that.
does it mean to converge?
Some of you guys might think the 70s were a really long time ago. It was only 40 years ago. So if you kind of think about that concept, this is a very new theory. And
Join
for
together, combine.
some of your parents,
Some
so with a conversion boundary, some of your parents, we have two
They will probably
plates that are coming together. What's
What's
happening? Brand new theory out on how continents are changing. So this is actually a very new concept. So we start off with this concept that puts it together. That the crust and mantle will show you images of enormous pieces that we call plates. Divergence is pulling apart. Convergence. So the first one is ocean to ocean. Transform. What you guys do is cross notes over this. I want you guys to look at the key. So that's all that transfer boundary is. Okay, so it's where we have two plates that are all sliding in different directions all over the globe.
Most of these occur at the ocean
types
ridges.
of plates. We get different geological features. Keep in mind, we are on a finite world. So in a normal convergent boundary, the plates just can't keep moving apart forever.
You have one
Piece across. So as you're moving apart in one location, what are you doing in another? Yes. This right here is called the subduction zone. Be subducted means you get pushed LA, San Diego area.
Now, if you think about this,
Oceanic plate, the Pacific plate.
take your hand,
San Francisco,
throw them together,
the North American plate.
and immediately when we think about earthquakes, we know that the earthquakes are related to plate tectonics.
Sorry, you start laying earthquake slightly massive northwest.
Okay, good.
Heat, pressure, all
What
of
else?
the United States.
What do they truly align themselves
with
That's not what I'm actually making now.
So eventually,
Now think about how much energy is released from an earthquake.
those three cities will be dangerous.
So I'm getting an arch on this side, the one that's not getting conducted. You know, if you understand a little bit of basic science, basic physics, how many guys have had ICP? Not the ridge. So that's all that is. And usually,
Or have had ice.
so you can see the trench, very, very shallow earthquakes right here. That's your trench. And just as you said, right, we get this arc
By shallow, we usually
coming up right here, right? And that's because all that stuff gets pushed up behind.
One thing you guys should learn,
And if you have not taken ICP, we'll definitely take it next year. Is that
Now,
things when they
I
move?
want to talk about why we get conduction.
fall through anything.
and then the slower you move,
That's pretty much it.
even though you're really big, that collision that
Why
you
would
have,
one? Because you're so large, increases the amount of energy that's released from the collision. What do you mean by
take
heavy?
two little gnats and fly at one another, you're not going to release a lot of energy. But take a massive
Not so much that it weighs
You're
more.
running into another continent. You have size. This amount of energy because of the mass shapes that are involved.
Oh, like taking two rockets from it, yeah.
Yeah.
The way it's
So it's like taking
the type of
material.
it's made of.
Take two smart cars.
Oh,
Have them
yeah.
travel at 5
If you
miles
mix
an hour.
water with oil,
And
what happens to the oil?
the collision with
Oil will find its way to the top. Why is that?
So you're fortunate like miles per hour.
Not lighter, not thicker. But now, take the same thing, but take two semis. Give me a more scientific terminology. Which one's going to release light energy? It's less what? There, it's less dense.
There we go.
And
So the
physics,
denser
plate
plate
is pushed underneath the less dense plate.
So
Right?
should be.
Now, I'm not sure you guys remember doing this, but remember we measured the density
values
of
of
granite
energy.
rock and basalt
So
rock.
the last thing we need to
Remember
do
doing that?
about then is
Which one was
Line
more
of
dense?
dense.
This concept.
no, it's the salt.
Where they intersect, we call that a plate boundary.
It would, so if you think
We
about
had
that, remember
three
your continental crusts
Major
are
types of plate
acidic,
boundaries.
your oceanic crusts are basaltic, and therefore when they
That's
collide,
why
look at
salt
most
becomes
of
more
today,
dense,
and
and
therefore
therefore
it's
it
analyzing these three types of underneath.
So it's all due to density.
But now, I want you to notice something here.
What do I have forming right here?
The first one I wanted to discuss is divergence.
They're volcanoes. Yeah. And how do we know
What
they're
does it mean
islands?
to diverge?
Yeah, what's the difference between a
No way.
volcano and an island?
Move apart. Think about dividing. Think about divisive.
And all those things mean to move apart. So in a divergent plate boundary,
There you go.
yeah,
it's
two
surrounded
plates
by
are
ocean
pulling
water.
apart. So if I got an ocean crust colliding with another ocean crust, what I actually get then, and this is what it's really
Now, there is an old school of thought.
Volcanic. Again, guys, you remember this is a slightly new theory.
Change.
Then there's an old school of thought that thinks that originally what we thought is that what was,
You can almost
what
think
would
of it
force
as
these
art
plates to move apart
A
from one
volcanic
another.
island change. Yes, the Aleutian Islands are a perfect example of that.
And what we were thinking is it's the welling up of magma coming up and therefore forcing the plates to move
mimic
apart.
the shape of the trench. They run
And that's kind
parallel
of the original
to the
thought.
trench.
So we used to think it was the magma coming up.
So that's why we start getting all these
volcanic
circles.
islands
It starts
along
to,
these
it comes up
trenches
like
that
this, and then when it hits that ceiling, it starts to spread out. As it spreads out, it kind of pulls and
again. And that's not really what's happening.
Well, those are
Uh,
actually volcanoes.
So one thing we're going to be talking about
When you think
tomorrow
about a volcano,
is this thing called ridge, push, slab, pull.
But most of them
Ridge
are
push,
actually formed with the
slab,
ocean
pull.
ocean.
That's what we'll talk about tomorrow. That'll explain more about the divergent.
So
plate
that's
boundaries.
ocean to ocean.
What I want you to notice. So again, we can look
Is-
at right here. Right, we have the Aleutian
This
Island
video
right
is-
here. That kind of shows you what's
Those are
really
all
happening.
volcanoes that are forced up where the ocean cross meets conducted
So-
underneath.
And we can see again, we have as we have this
Japanese
upwelling of
islands.
magma, it pushes the
all
plates
the way down
apart.
to here to the
You
Marianas,
can kind of see that
as well as the
coming up,
Philippines.
pushing the plates apart. These
Now-
are all examples
of plate tectonics taking place.
Every
Most
single
of your
day.
divergent plate boundaries are on the floor. Okay, so that was ocean to ocean, and that's what causes our ridges.
Okay,
Now let's talk about
first
ocean
you see
continents.
those ocean ridges. That's indicative
What's different?
of a plate boundary and divergent plate boundary.
Looks exactly the same, but there's something
It is
different.
extremely rare to find a divergent plate boundary.
Good. So, all right. So this side over here is definitely a continent.
But it doesn't really
It's above water. Go ahead.
It's not considered
It's not.
Once you stop,
There's definitely volcanoes though.
once you think about where
So what do we call
on the
these?
planet that we might have divergent plate boundaries on the continent.
Let's say you were driving along, and then you see this. What would you start calling those? Mountains. There we go. So when you have ocean and continent, you don't get volcanic island chains. Instead, we get volcanic mountain chains.
So like
Mississippi River is a perfect example of a divergent plate boundary.
Say that again.
Where else? Nope, not Nile.
Oh, the island chain or the volcanoes form because
As this is being
The
conducted,
Great
there's
East
so much
African
heat and
Rift.
friction that the rock starts to melt, and therefore becomes
So let me
less
take all
dense
these off here.
than the surrounding.
So
actually
when
all
they,
that matter
because this
is
is something that's really important for you to
surface.
know. When they do
Which
occur on
then
land, we
even
call those
then
rifts.
increases the amount of ripples that we start to
Valleys.
see. Therefore, we see the volcanoes form.
But I'm talking about
Okay, so a rift valley is where the divergent plate boundary
This
is
right here.
occurs on. No, this is all the original continental crust.
Yeah, the New Magic Fault is
So you
basically
take your
divergent.
fingers and you run them together. This hanging over here is going to start crumpling up. Now, when you look
It's
at
still
the East
moving.
African Rift, but as soon as it hits that ocean plate,
One of the
you
things
get
that you
friction
notice
that keeps it from.
is that we actually have
Easy
several
slide
divergent
forward.
plate boundaries.
So you get all this
We
back
have
up.
one right here along the Red Sea.
It's like having several people walking a line
through the Persian Gulf.
Probably do this a lot in elementary school.
So you actually have
They make you guys
Africa
like the chain gang, walk down the
pulling
hallway.
apart from the Arabian
One
plate.
person stops abruptly.
The Arabian
but
plate
then
also coming off of
everybody
the
piles
Arabian
up
plate.
behind them.
It's the
So
same concept
both of
right
those
here.
are kind of like just
When this
split
front
off like this
edge
away from
stops
Arabia.
abruptly, what happens to all the material behind it? Piles up behind. Now, what I want you to really
So a
notice
lot of
is
times
right
your
down
mountain
here,
chains
we got the Rift Valley.
are another
What you should
way
notice
of
is we have
identifying where we
several
have divergent plate boundaries.
so is that how
You guys see those in the back?
I know it's a light image, but can you see those? No. Why is
What
that
am
a
I
whole other issue? So, these form volcanic mountain chains or volcanic arcs. Okay.
Yeah.
So we're going to see that here in
In
this
fact, what we actually have are it's called a chain of lakes, and they're all fed by one
We're going
river.
to see where, as that is being
This one
conducted,
river
the heat
literally feeds in from
forces
one
the
lake
magma
upwards.
upwards.
And these are very narrow lakes and extremely deep
compared to
lakes.
volcanoes.
And it's spawned from this Rift Valley because if you think
Some
about it,
examples of these are
if I take two
mountains,
blocks,
the Cascade
and
Range,
move them apart,
we
what
have
happens?
the Rocky Mountains through British Columbia, all the way up through Alaska.
the
You
low
have
area, which this range, all these are major volcanic chains.
The Alps are another example.
So it totally makes sense that we have this long chain of lakes that goes all the way up here from the Gulf of Aden, all the way down here, past
I'm gonna
Madagascar. In fact, that
I would say yes.
the straits right here between Mozambique and Madagascar,
Well, they are. They're very
divergent
old.
plate boundary.
They're a lot older than the Rocky Mountains.
And basically, what you
And
really
the reason we know
have
that they've
is
been
pieces of the
eroded that
Indian plate
That's how we
separating
know how old they are.
out
They're a
from
lot
the
older than the Rocky Mountains.
So yes, in the
They're a
near
lot
future,
smaller.
and by near, near geologic future,
Future, I would say that's
those pieces of Africa will no longer be part of the African plate.
And that was very
Okay,
good.
the last one I want to talk about is
So that's an
continent.
example.
Continent, a perfect prime example.
And I did
of
misspeak
Rift
on
Valley.
this.
Now we have some of those
The
here
Alps
in the
is
United
not an
States.
example of ocean to continent. The Alps
The
are
Mississippi
continent to
River.
continent.
Now, one of the things I want to make sure we point out, Missouri, is that now we have two types of cross. We have
very
a continent and a continent coming together. But what I want you to notice